So, welcome back students. I am sure this quantitative finance program till now whatever lectures we have covered is quite exciting to you, and you are getting interest in this new course specifically designed for people who are really interested in quantitative finance, faculty members who are interested. And I am sure with this little background, considering the 20 hours of lectures we have and considering that we have to cover a lot, this will definitely give you a good head start in trying to pick up different concepts from different books, different URLs, data sets and so on and so forth. So, again let us come back to the topic which we are discussing. It was basically to do with the put called parity. So, depending on when you have an option, so it can be call and put, and obviously put and call can be short and long. So, you want to find out the parity at which the prices can be determined such that either the seller or the buyer does not make any extraordinary profit, because you should always remember that the options or derivatives whatever are being studied here are from the point of view of trying to minimize your overall risk. So, you are going to go through for some financial transaction and your main aim to reduce the risk. So, that is why we are trying to utilize different type of derivatives, like we have dealt in quite detail about swaps. So, they can be interest rate, they can be currency rate, they can be combination of that, then options can be call and put, forward futures are there. Then we already considered that how you can, if you go back earlier in the beginning of the course, we have considered in depth different type of optimization model, the safety first principle, maximizing RF and so on and so forth. So, I am just trying to recollect. So, your main aim is always to reduce risk. So, for non-dividending paying stock, coming back to the slide. So, we want to find out what is the lower bound for the European calls for non-dividending paying stock, that means intermittent payments are not there. The lower bound is given by H0 minus x e to the power RT. So, even though it may be a repetition, but I would like to highlight again that the value S0 is basically the spot of the stock as of now with the suffix 0 means. X means x or k means the delivery price which will happen at time t is equal to capital T, and when you multiply it by the term e to the power minus RT, you basically try to bring the price as of now. So, let us consider again, I am again rehashing the same example. Portfolio A has one European call option plus an amount of x e to the power minus RT. So, remember it is a call option and you have this amount of cash. So, now if you consider at which at time t this combination would be worth max of ST minus x. So, how does it happen? Because if you are a call, you want to buy back that particular stock or commodity, whatever it is. Now, if the delivery price is x and ST is the actual price, the moment the price is higher, obviously you will try to go into such an option that the person who is the buyer of the option would exercise that if and only if this condition holds. Now, what we have is that S0 is increasing, it is increasing at this rate and this is equal to ST. So, now you have already decided on a price of x or k, which is based on this equation. Now, if this is greater, less or equal to ST, that will dictate whether the person will exercise or not exercise depending on who is the buyer. Now, that would the equation which is given is that will be worth the maximum value of this if and only if it is a call option. So, for the put it will be just the opposite. I will come to that again. Now, portfolio B has only one share which as time t is ST. So, now you are basically has two positions. One is portfolio A which has one European call plus a cash, and portfolio B has one share. So, in case if there is no profit and loss in going to for portfolio A or for portfolio B, they should balance each other. If not, there is no balance, obviously somebody makes a profit or somebody makes a loss. Hence, the value of C based on which the contract would be signed between the buyer and the seller, the buyer is paying that price, that would depend on two terms. So, this is the value as of now the value of the so called spot, because this is the price of the spot, this is the price of the delivery price counted by e to the power minus r t to bring it as of today. So, difference of them, if it is positive or negative, if it is negative obviously you would not. So, because the C value would always be greater than equal to max of these values, which is 0 or negative. So, it will be 0. In case it is positive, obviously in that case C would be greater, because in anticipation this value would be positive, which means the net present value when brought back to this present value, net present value of this amount when brought back to the present amount is less than S0, because if that is the case, then the value of the C would be dictated accordingly. Now, when you go to a put option, just reverse the situation. So, here it was initially it was S0 minus x e to the power minus RT, now it is basically minus has been replaced by plus here and a plus has been replaced by minus here. So, let us consider two different portfolios again for the put option. Here portfolio C has one European put option, there it was a call option. Put option plus 1 share, which as time t would be worth exactly this. This is the same thing as we are doing. And portfolio D would have x e to the power minus RT amount of cash, in that case it was a share, now it is a cash, which at time t would actually become xy, because if you had some cash of x e to the power minus RT and this will increase, but increase by the term of e to the power RT. So, these would cancel. So, the actual value would basically have is x. So, hence again the same logic, the difference between x e to the power minus RT minus x0 and 0, whatever the maximum value is, your value of p would be, that is for the price of the put option, would be calculated accordingly. So, with repetition I am again saying, whether a buyer or a seller, that is immaterial, but just consider if you are a put, you want to sell something later on, if it is call, you want to basically buy something later on. So, your prices of the put and call, that is small c or small p, for the case when it is your European position and your time duration is capital T, would be dictated by the max of the values. The second one, which is basically given in this slide, and the first value has been given in the previous slide. So, let us consider an example to basically clarify the conceptual thing about put call parity. Parity means there is some balance. So, you consider a portfolio has A has one European call option plus an amount of cash which is x e to the power minus RT, because in that call option would increase, obviously you will exercise it at time t, and the cash will increase by the value of e to the power RT. So, it becomes x into e to the power minus RT into e to the power RT. So, the net value becomes x at time t, and portfolio C has one European put option plus 1 share. So, in that case if you basically balance both of them, that means if for the call option it is C and for the put option it is P, where this is the case here and this is the case here, because if you see x e to the power minus RT is here, that means it will increase, but it will increase by this amount and this will also increase, this will increase by this amount, which means this value and this value, if they are same, then the actual values of the difference of the C and P would basically be 0. That means, they would be a parity or equalness value in the C and P value. Again I am repeating, this will increase by this amount, this will increase by this amount, which is e to the power minus RT into e to the power RT. So, they cancel. So, this is x. So, if this is equal to S0 e to the power RT is exactly, if we go back to the original concept, where you had a price of S0, it increases by these values, this should be exactly be equal to x, as that the person will be willing to buy or sell that particular call or a put. Now, if you come back, if the difference is 0, so obviously it means the difference between C and P is also 0. So, in that case there is a put call parity. In case if x is greater, equal to, less, in this equals case you have P is equal to C. In case when this x is greater or less, you will basically have a put call disparity, or there is uneven difference in the prices of P and C, which is the put price and the call price for the option which somebody is buying. So, now for the dividend case, follow exactly the same thing, but in this case remember, for a dividend, when this dividend case is being paid, remember this would come, where this I0 is the present value of all the intermittent payments. If you recall the concept of zero interest rate or forward interest rate, whichever you calculated, we have calculated the concept that some dividend is being paid on a continuous basis. There is inventory cost or storage cost, then inventory cost, storage cost is continuously compounded, and all these concepts like the value of Q, value of capital U, capital value of small u, all these things can be considered in the same way as we have done earlier in this case also, to order to understand what is the relationship between small c and small p, which are the call price and the put price for the European options. Again, here also you will exercise, early exercise would be happening the moment the price differences are this. So, if there is equality, there is no difference in the prices, that means people would go into an option thinking that nobody is going to make a profit, nobody is going to make a loss. That means put call parity would be maintained. In case not, it will not maintain. I will strongly urge, in order to understand this actual concept, please solve the problems which are there in John C. Hull. Point 1. Point number 2, there are small problems which are already solved. Point number 2 is that read the concept of put call parity after you have completed the concept of forward, futures, swaps, options, and the interest rate calculations, such that things would become much more easier for you to understand. Now, effect for the dividend. So, as I mentioned the I0, here I0 is being replaced by dV, which is dividend. Now, in the same case, this is the same case, S0 minus I0. So, actually S0 is now not only S0, that S0 has been subtracted by the value of I0, which is the net value of the intermittent payment which has already made. So, if this is one intermittent payment, one, second, third. So, all these things basically calculated at time t is equal to 0, that is basically I0, which is dV. So, in the similar case, portfolio A has a European call option plus an amount of cash equal to, now is dV is the basically the value of the dividend values which we will be getting. So, in technically, initially if you remember, we had considered S0, now we would not consider this, you will consider S0 minus I0. Now, if I ask you the question what happens for the continuous dividend yield, it will be S0 e to the power RT, and another term would also come is basically S0 e to the power Qt minus, minus means because it is R minus Q, as in the case of the continuous yield. So, similarly for the put option, again consider the same thing. This is the value which you had S0 minus I0. In one case it will be minus, and in the case it will be plus, depending on whether it is a put or a call. So, only understand again whether it is a put or a call, depending on that whether you want to sell or buy later on, your prices would be dictated accordingly, and you can find out the put call parity in those cases. So, if I go back, let me go back one step back. So, in this case, when you are trying to find out the put call parity, this S0 is no more S0, it will basically be S0 minus I0 depending on how the dividends are being calculated. So, here you see this value, because if you bring it here, it will become minus dV. So, this is S0 minus I0, and in the case you have continuous yield, it will be basically e to the power minus RQT. So, relationship between the American put and the call would basically be the same thing. So, the difference between this price would be between the bound of the no dividend and dividend being paid, because you will basically exercise that if and only if the prices are in between, or else somebody will make an extraordinary profit and somebody will make an extraordinary loss. So, you can solve these simple examples. So, what is the lower bound for the price of a 4-month call option? So, remember 4 is basically 4 by 12 in the time scale of year. On a non-dividend paying stock, when stock price is 0 and your strike price is 25, which is K or X, and your interest rate is given by 0.08. So, this is basically R, and this is S0, and you can find out the corresponding value of put or a call parity is there, you can find out the prices. In the case it's dividend paying 1. So, here the stock price is 64, strike price S0 is this, dividend has been calculated is being paid 1 month, is a 4-month period for 4 by 12, interest rate is given 0.12, which is RF, and you can find it out accordingly. So, now considering the concepts, we will continue our discussion, where we will slowly expand our discussion in the sense, till now we have considered a forward on a standalone basis, futures on a standalone basis, options whether a put or a call, put long, put short, call long on a standalone basis. That means, you were only dealing in only one option. But now consider what we start combining them. Combining in what sense? Say for example, we have one put call, one put and one call plus a forward. Or say for example, if you have 2 forwards plus 1 call, or consider we have 2 different forwards at different prices, or say for example, consider you have 1 European call option and 2 American put options. So, if you have different combinations, the main focus would be what do you think about the price fluctuations. Is it going to going on an increasing trend? Is it going on a decreasing trend? Is it going to fluctuate between 2 values, or is it going to basically hover around in and around some value? So, based on that you will basically make a plan such that you can buy, sell, put, call, go for a forward, go for a futures in such a way that you will mitigate your overall loss. That means, your main aim is, again I am stressing, is to minimize your overall loss or the risk. So, in the first chapter we had discussed the payoffs of the profits from a investment in a single call and put option only. This is again I am repeating. The question is that what happens to the payoff profit patterns using different options now. So, different combinations. So, let us go one by one in a very simple method. We will consider both the diagram plus the profit matrix. Profit matrix is that as ST changes, and as you have 2 different, 3 different, 4 different delivery prices for different type of options, different of call and put, we will combine them accordingly. First draw the matrix, and then from the matrix try to basically find out the diagram, or else if you think it is easier, you can first draw the diagram and then basically derive the matrix. Whichever you do, the answer would definitely come out to be same, but you have to understand in conceptually that as ST varies, how does it affect the overall profit and loss for the combined option or a pool of option or a portfolio option which you are trying to formulate. Now, consider this for the first thing, we have 2 things. One is a long position in a stock, that long means you are going to, their concept again recapitulating, long and short. Short you want to sell, long you want to buy. So, you are basically going for a buying position in a stock, and you are going on a selling position on a call option based on the stock. So, you are basically taking 2 different modes. So, if it is a long position on the stock, so I will mark it, this is the red one, and if it is a short position in a call option, so this is yellow I am using, hope you can see. So, this is the call, and this one which I had marked in red is the long. So, now if we combine them, the combined position looks like the one which is marked in the bold. So, now think what is the advantage, why have you done it? Now, if you consider the prices of an increase of ST over K, so you will see that if you have only gone for a long position, bought the stock at some point of time down the future, and your price agreed upon it was K, and the price is increased to value ST which was greater than K. So, obviously, you would have made a profit, because you bought it at the price K, immediately sold in the market and made some extraordinary profit. But think what would have happened if the prices was low? Still you have to basically buy at K. So, that means you would have made a loss if it ST was less than K onto the left hand side. Now, consider you are going for an option and you have sold that option such that the price agreed upon you have sold, price agreed upon for this is again K. Now, what is happening is that if the price is less ST is less than K, as you have gone in an option, the buyer of the option would not exercise, which means that you are not going to make the loss which is being shown here. So, you have mitigated that, but obviously, if you mitigated that, you should also think what would happen if the prices were greater. If prices were greater, obviously, you are thinking you will make a profit, but the person who has bought that option will definitely exercise that. If he or she, other party, exercise that, the overall loss would now be this portion, which means now you are saying that you are going to face a loss. But if you combine both of them, it will even out. How? Any increase which is happening here is positive, any increase which is happening on the lower side is negative. If you combine them, the overall combined long position on a stock plus short position on a call option would be parallel to the x axis, and the overall loss of profit would basically depend on this portion. So, now this need not be just above, it can be little below or towards 0 also, that does not matter, but what have you done is that you combined the long position, combined the short position in such a way that for any negative price movement of ST less than K, you have been able to mitigate or lessen the overall impact, but on the other hand any positive movement of ST greater than K, there also you have been able to mitigate the overall loss to a maximum possible extent, because your main motivation is not to make profit, in order that when you have actual dealings with options and futures, your main or stocks, your main concern is basically to minimize the risk. So, with this we will end our class today, and we will continue discussing different type of positions of combining different options, different forwards, different futures in a long and short position. And as you continue doing the examples in options, future and forwards, you will see that trying to formulate different combinations on options and forwards with different strike price, different timing, time duration would definitely give you a good feel that how these problems can be solved. Thank you.